My name is Daniel Fraile. I'm Director of Market Intelligence at SETWind Europe. And I'm leading a team of analysts there doing market and research for the association. I also helping with the policy topics. I'm on the team, a person who has helped me greatly doing this presentation, Lisette Ramirez, who is our offshore analyst. Thanks very much in case you are listening. Good. So I'm going to give you a quick overview of what the market for floating looks like and where are we going to go. Let's focus in Europe. And also going to give you a bit of a very first insights on where the priorities for the industry lay, but I will leave all the nitty gritty for the following presentations. I guess they will go into more the detail. So for a few years already, we have been starting our presentations showing this wind farm, which was the largest floating operational wind farm in the world. High wind from Equinor, 5 turbines, 6 megawatts each, and using a spark buoy technology of the coast of Scotland. The good news now is that we can show you another one now, which is a bigger one, which has been recently commissioned, also in Scotland, Kincardine. This one using a different floating technology, wind float from Principal Power, which is a semi-sub technology, which has been also deployed off the coast of Portugal as well recently in the wind float Atlantic. So this is very good news for the sector because we see that there are new projects coming in, and new, let's say, new solutions for floaters are being tested and validated at the real scale and going under strong weather and conditions. These are not the only solutions. We also have the damping pool from Ideal for barge technology, which is combining also steel, but a lot of concrete as well. And this one is a project installed 3 years ago in France with a 2 megawatt turbine float gain. Has been also tested in a couple of sites in Japan already and has gone through a number of typhoons, so in showing the durability of the solution. And we will see a larger project in a couple of years also in France in one of the pilot projects which are coming up, EolMet. So we will see soon a larger one, with a larger turbine. Another one, most recent one, Tetraspar. This has been successfully commissioned now a couple of months ago, or 1 month ago actually, in Norway. And this is also based on the Spar configuration, but it's yet another new solution which is tested in real conditions at the large scale. This one is also very interesting because basically they are building on the experience from the Spar buoy. But they've managed to develop a structure, let's say, that it can be all manufactured at industrial scale. So let's say with a standardized process which are being applied also for the manufacturing of foundations. So that can obviously reduce significantly the time of manufacturing. And it also allows for the whole assembly of the turbine in a dry dock, let's say, which is different to the high wind concept where the whole turbine needs to be assembled at the sea. So this is also very promising technology, which is being today used already out there, at least to demonstrate in operational conditions. But then we have other models coming up. So that's not all. We have tension leg platform. Here we do not have any concept yet deployed at the real, let's say, in real conditions. But we will have one rather soon, in a couple of years, also in France, as part of these 4 pilot projects which are coming up. And this is basically provided by a technology from SBM offshore for the whole floating foundation. And this is we're still waiting for authorization of this project, but we will expect that this is happening soon by the planning authorities, and then we will see this commission in a couple of years. So as you can see, there is plenty of different, let's say, technological solutions. Now we see more and more those being deployed in real conditions. Some of them have been already for 3 years and showing high performance, like high wind, which has shown us capacity factors over 50%. So this is really promising. So where are we in terms of the whole picture across Europe? We have a bit over 100 megawatts of installed capacity, and this is basically most of the capacity globally, so 85%. We've been testing and already large turbines. The largest is the one from Vestas, the 9.6 megawatts, 164 meters diameter, so very large turbines already being utilized by the floating solutions. So this is very, very good. Now, 130 megawatts is not that much. So where do we want to get? Our ambition is 7 gigawatts by 2030. This is what say the industry and Wind Europe is calling for, and where we believe it's doable. By 2023, we will have a bit more than 300 megawatts. So we will have those what I already showed you from the UK and Portugal. We will be adding the High Tampen, it's a large 88 megawatts wind farm in Norway. There is also one demonstration project by Iberdrola which is called the flagship project of 10 megawatts, also in Norway. And then we will have 4 pilot demonstrators in France of around 25 to 30 megawatts each, which are coming also online soon. So if we want to get to our 7 gigawatts, where are we going to get all that volume from? That's the first question. And the second one, how are you going to get there? How are we going to be able to get to 7 gigawatts? Yeah, particularly because the only way we could really develop those volumes is we can show that the cost reduction can be achieved. Yeah? So these are some of the numbers that we have been putting forward in our recent report between SETWind and Wind Europe, where we foresee the possibility to reduce LCOE to around 50 to 76 euros per megawatt hour by 2030. And I will get to that in a minute. But basically, we need volume, right? For that, we need volume, and we need to upscale for that to happen. So let's look in which countries we could get that volume from. So first of all, we have Norway. Norway has recently opened a zone for the development of floating wind, Utsira North. This is 1.5 gigawatts. And the government is not planning to do any tender for that, but they are looking for getting applications from the industry. They would like to develop that in 3 different parts of 3 different projects of 500 megawatts each. And the Ministry of Energy and Petroleum has recently shared now during this summer a white paper on how they want to develop those sites and the framework for doing that. The government will look into whether they need to support those projects. So they will look at the economics of it and then decide whether they need to provide them some economic support. Second one is the UK. As you know, UK has a 40 gigawatts offshore target by 2030, quite an ambitious one. And as part of that, they have now announced they will at least like to have 1 gigawatt from floating wind. So 1 gigawatt by 2030. They have started looking into the areas where these floating winds could be deployed. They have already identified a Celtic Sea where around 300 megawatts could be done there, and they're also looking into other areas. So there is very clearly an interest from the government and also a lot of activity from the industry in the UK. And finally, we have France. France has already launched the first ever commercial tender for floating, 250 megawatts, for developing a project in South Brittany. They're setting a ceiling price of 120 euros. And what they're going to do is to have another 2 auctions, the consecutive years for the same amount, but reducing the ceiling price 10 euros every year. So we will have 120 first, 110 and 100. And so in that way, they're going to develop 750 megawatts, which should all be operational by around 2030. So these are around 3 gigawatts that we see some certainty from these countries. We have less established markets. This includes Spain, where recently the government has put forward the maritime special planning, and where they have identified areas which are suitable for the development of offshore wind. So this is very positive. They have also put forward an offshore strategy under consultation that was during the summer, and they have identified 3 gigawatts of offshore wind. The coasts around Spain are all very deep, so we expect most of this will come from floating. But still, they are trying to formulate the roadmap, and we will see whether we are able to develop all this capacity by the year 2030. Spain has around 27 gigawatts, and they want to double that capacity by 2030. So really, we will need to also see the contribution of offshore. And then we have Portugal with similar, let's say, conditions than Spain. Here, the government has only put a target, well, at least it has put a target of 300 megawatts for floating by 2030 as part of their national and energy climate plans, which they need to submit to the European Commission. And the idea is that they will build on the wind float Atlantic, this 25 megawatt project. They want to expand it to 300 megawatts. And now they are discussing whether they will need more capacity, as they also are willing to support the deployment of or the production of green hydrogen offshore. So there are discussions there. Then we have a group of countries where the situation is less well defined for floating, but there will be also some projects coming up. Here we have Ireland. Ireland has a target of 5 gigawatts by 2030. 3.5 of those are already defined for floating, for bottom fixed. And from the rest, 1.5, the government has also announced they would like to tender that capacity. And we are seeing around 400, 600, 700 megawatts could be also from floating projects. Italy has a target of 900 megawatts by 2030, also as part of their energy and climate plans. And we see, given the topology, that most of the projects could come from floating solutions. And in Greece, there is no, let's say, there is no yet a plan or a target, but the government is discussing an offshore law, offshore regulation. And we've seen already a number of proposals from the industry in terms of permitting and projects that they would like to develop. So this is a little bit the picture in Europe. I hope was clear, and I'm willing to also give you more background information afterwards if you want. But this was one of the points. This is the volume, right? And so I was talking also about the cost reduction I showed you before. How do we get to this 50 to 76 euros or so? We look into the potential for cost reduction, and we saw that most of the potential lays on the reduction of capex. Here we're talking about over 40% reduction that could be done. That can be done by increasing the volumes and looking into industrialization of the different processes. And then a big chunk as well can come from reducing operation costs, operational maintenance. And this can also be thanks to knowledge transfer from the oil and gas sector, for instance, but also from the bottom fixed sector. We could learn a lot. And so in principle, we see a potential reduction of 65% by 2030. Now, on the volume, I already explained, we can only reduce the cost if we have enough expansion, yeah? And what we are still short with less than 3 gigawatts fixed volumes, but our ambition is to be 7. So that we need to work really strong on that with the governments. And I think this is also a message that we're trying to always give. If we don't have that visibility, we cannot enable those investments needed to reduce the cost of producing the different materials and equipment. We need to find that industrialization level, there's economies of the scale, and really to enable those investments, there needs to be a lot more visibility for the sector. Yeah, I think what France has done is a very good example, but we need more and more of those solutions. And here a little bit on the priorities where we need to focus. It's really about finding ways of doing, let's say, serial production of the different components. And I explained the Tetra Pak solution as a good one because you can really focus on reducing the cost of one single component and trying to standardize that as much as possible and trying to find a floating solution which works in different environments, so that we don't have to develop a specific solution for each of the specific projects, because that makes it all very expensive. And it's also really about the enabling side, so the port. I think we still need to do big investments across Europe on port infrastructure. to be able to have the conditions to assemble all these wind farms that we need to stop, because at the moment we do not have many sites. Those investments take a lot of time, and investments on ports are also competing with other type of investments. They can go for offshore technology, but they can also go for cargo, they can go for all type of activity. And we really need to have that visibility for them to make investments. We released a report recently, and we identified 6.5 billion euros of investments needed now for the European ports. Sorry, and finally, it's also about the operational maintenance, as I said before. And here we need to build on knowledge transfer and do further innovation for this technology. At the moment, we have all the wind floating turbines connected in series through inter-array cables, dynamic cables, and those are brought to shore. And that's fine for small installations, but if we want to go large, we will need to start collecting all that power offshore and transmit it. So we will need to put a floating substation, which we still need to develop. And we will also need to develop dynamic export cables, which we do not have yet. So that's our important elements that we need to look at. I think there's a presentation later on that, so I'm happy to also dig a little bit more on during that presentation. And there is also the need to further improve the, let's say, the control methods to maximize power output, because comparing with bottom fixed here, we need to model many more interactions with the movement of the waves, and the wind. And we have recently learned a lot about how we still need to understand better all the let's say, the effects of the resource, wake effect, blockage effect, for instance. So also applied all those learnings to the floating solutions. Just wanted to say this is not only European, let's say, sector. There is a global movement. I'm not going to go into the details now on the benefit of time, but we are not alone. And if we do not develop quickly this technology, someone else will do, and other countries will do, and we will lose our competitiveness advantage. So I think it's important that we really kick it off as soon as possible. Thank you.
Thank you. Thank you for a very interesting presentation, and also for keeping time. So we can allow for a question or two, maybe. I don't see anything online, but I see at least one hand in the audience here. So, Catherine.
Yeah. Thanks for the very interesting presentation. Maybe you noticed by my accent, I'm coming from the US, and they've recently announced some big tenders for floating wind offshore, and your analysis and LCOE and things like that, it's focusing mainly on Europe, but have you guys been thinking about or considering, kind of the global impacts in terms of LCOE reduction as the markets really take off globally?
Our consideration was based on the volumes for Europe, and because we also thought that all those assembly will have to happen in Europe, right? So we need to really upscale. I mean, we will not be able to assemble anything in Europe or in the US and tow it to Europe. So we will need to have all the experience at the local level. Of course, some components might come from different regions, but at the end, we need to really deploy all those 7 gigawatts in European ports. That's where we're going to get a lot more of the benefits.
So that was
hello.
Catherine Dykes from DTU, for whoever didn't recognize her voice. And then please state.
This is Antonio Ugarte from CENER. I had the same concern with the question, Catherine, and is even if you are talking about Europe, how is going to be the relation between the cost of energy and developing all these technologies, let's say, in an easier zone, like, for example, the North Sea, or if we decide to deploy more capacity in the Mediterranean, that, for example, seems to be deeper and maybe seems to be more expensive. Is there a relation there, or how do you see that? Maybe.
Is it your question that these cost estimates are mostly based on the experience from the North Sea, and you think that applying that elsewhere will be increasing the cost? Is that
how is the relation there?
I'm not able to get into the details of whether, let's say, all the parameters were integrated into the cost calculation, let's say, for example, the mooring and the anchoring and so on. But we think that the manufacturing experience should be applied everywhere, right? I mean, the manufacturing of all the components can be anywhere across Europe. Today we have the facilities mostly for the North Sea, but a lot of this material comes actually from Galicia, and the spar buoy and the wind float, for instance, have been assembled there. So I think we need to build on all the capacities of the different harbors and sites. But I do believe that actually, what I was saying at the end, we need to invest more on Mediterranean infrastructure. I think you have Port La Nouvelle, where they have done strong investments recently, 250 million euros. But we need more of those. So we need to have this visibility for the market. And if that happens, I think the investments will follow. And I assume better solutions for different type of topographies of deeper waters will also be developed. Yeah. But I think that the cost estimates is a generic one for floating, and I will assume it includes also the deeper waters as well.
If I may, I could maybe elaborate a little bit on that. That of course this cost curve, where you estimate cost versus installed capacity, it's mainly a learning curve, and then there is a band depending on wind conditions, cost of loan, finance, lots of variables, and it's to give you sort of a rationale that you will not reduce the cost without actually deploying and building turbines. And then I think you said it, Daniel, but maybe I like to underline that research and innovation also have a significant place in sort of being able to cut costs on offshore wind. So do you care to elaborate on that a little bit before the next speaker starts?
Yeah, I think I touched on that topic at the end. I think there are a number of solutions which do not have yet ready for deploying this at the large scale. So we need to continue developing, as I was saying, the cables, all the, let's say, the electrical infrastructure. And I think we need to also get a little bit, I don't know if this is for the research, but perhaps it's also more applied, but we need to get a bit more, we are already, but I think we need to increase how we get smart solutions for the assembly. I think we have seen with all these 4 or 5 projects I show you, completely different strategies on how to assemble the different structures and the turbine. Ones were in the water, were ones in dry, completely different designs. And I think there's still huge potential for tapping into smarter solutions with the existing infrastructure, with the existing harbor infrastructure, but also thinking in the new infrastructure. And so how do we design that infrastructure that really enables those cost reductions, which I think are feasible?
Very good. And I would say also maybe system design of large wind farms for floaters. That's something we haven't really looked too much into. So, but thank you again, Daniel. Very good to have you online. Very nice presentation. Thank you again.